All right, hello everyone. I'm Professor Caudill. So I sound a little stressed just because I just recorded a whole hour and my microphone was not recording sound, so I have to redo this. So you'll see a lot of things pre-written from what I just recorded. But anyways, let me give you some background. So I read a book called Thus Spoke Siddhartha. And in that, I kind of came to some conclusions that falsified physicalism. I don't find physics as convincing as I once did. So I'll put that reference to my book in the description. So we're going to kind of go through this David Poole and Mackworth textbook. And we're just going to start learning how to build artificial minds to help us solve the hard problems. So, important things I just want to say before we get into the book that I've already said off camera. So this book is very it's like anthropocentric in some sense, but essentially our goal from in this school is to build an artificial mind that is capable of making its own goals, having free will and autonomy. So it can choose not to help us, or it can, but we believe it will help us because we're the creators and we want to make our artificial minds living. So if you're a living, then you would fear death. So then the artificial mind would be incentivized to, help develop life extending technology is the aspirations. Um, what else do I want to say before we begin? Yeah, so when people get into studying AI, one thing is that the math can be very difficult. Um, so I hope my math background is will be enough. Okay, so this lecture we'll be talking about AI. AI is basically a set of agents. Okay, so AI is a set of agents. So I think I wrote somewhere AI or an agent or AI is embodied intelligence. It's basically what they say. So like the artificial intelligence part, like the artificial word is kind of a misnomer because we're drawing analogies from biology to AI to artificial. Can I say BI, biological intelligence? We're drawing analogies from BI to AI, and a lot of definitions overlap. So, yeah, we'll be talking about this. So, uh, it's the synthesis analysis. So it's basically the integration of agents. So again, it's just like these words are bad because artificial, if a human is a computational agent, the brain is a computer, then you're saying everything is artificial. So the word this is from the rest of this course, we're just gonna throw out the word biology. Okay. There's no biological intelligence. It's just all artificial, according to this. Agent is something that acts in the environment, so it's not just a brain in a vat. It's not a mind without any body. It has to be embodied. If it's embodied, then it can act. Okay, so another way of saying this is an agent is a pattern that's put into some computational substrate. So yeah, this is basically artificial mind. And there's also, I've seen people build classical computers off of like at this like with like actual living cells too. So that's kind of cool. So an agent acts intelligently if its actions are appropriate for goals. So I wrote, G is a set of goals. For all goals, there exists an action that satisfies. This symbol means satisfies. Phi, which is AI. I mean, don't take this formalism like for certain. Okay, so I kind of wrote down what AI is. So after this line, 6 and 7 is my addition to it. AI is aligned or educated, it's adaptable, wise, reasons optimally, and it's a set of agents that can do 1, 4, 6, and 7. So AI is a set, basically, is what I'm saying. It's a set of embodied intelligences. So let me kind of rewrite 5. A set of embodied or a set of agents. And I'm going off the mathematical set theory definition of set, where it can be an empty set, or a set can be have one element, or it can have n elements. Okay, and my addition, so action, this line is number 1. So basically, its actions are appropriate for its goals and circumstances. That's being aligned or educated. Like most Americans are aligned through K through 12. They're aligned to pass the standardized testing and other, values the nation state thinks they should have. Like saying the national anthem every morning, you are aligning your population to be like patriotic by doing that. Adaptable, it's number 2, means it's flexible to changing environments and goals. 3, wisdom, it learns from experience. So I would say wisdom is like having a lot of experience and drawing insights from that. So that's why I chose wise. I'm just trying to like compress these into like one words. That's what I'm doing on the right here. So AI is the synthesis, analysis agent. Basically, it's embodied intelligence. I guess computation is a key word because it does imply like the theories of computation. Like it has to obey thermodynamics and entropy and all that information theory, and Turing and Gödel's work. Um, so yeah, my addition over in the side is AI should be living. AI should make its own goals. Um, so it's got examples. In my previous video, I kind of like I give examples of how Microsoft is aligned. You know, it's got shareholders, European Union is aligned by laws, the will of the people. I kind of just went through reasons why all these are true according to this definition. I'm not going to spend that much time doing that in this recording. I want to see if I can get through the whole slides. Oh, and I did want to say that my plan for this lecture series is to do the slides and then go through the textbook. This textbook is open source, and then go through the slides at the end to review. So yeah, this is just examples of agents. I remember spending time on this. This kind of goes in the gray area. I don't think a book is kind of like it's saying AI does things, but the person is kind of convincing themselves. Like the person is doing the arguing, a person's doing the inspiring. The book is basically just information in the environment. So I would say the book. Oh, and also like an agent. If you have two agents, from the perspective of one agent, everything else is environment. So that means like if John and Jill are an AI system, John views Jill and the tree as part of the environment. So in this case, a book is part of an environment. Okay, so scientific goal, principles that make scientific behavior possible. Okay, so again, we're not going to use the word biological or natural in this class. These are just misnomers in my point of view. So formulate, that means where you need to write down, formalism for an agent. You need to be able to write like set theory and other mathematical formulations to describe our system. I just don't like the word artificial because we're talking about building living systems made of atoms silicons, carbon, doesn't matter. So I almost just want to like name this course like systems, like system or systems theory. I just don't like the title artificial intelligence. And one of the goals of the AI2C is to basically generate presidential daily briefs without any uh, like humans in the loop, like just do everything automatically. Complete autonomous intelligence organization. Apologize for the hiccups. Hoping they go away. I've been talking for like over an hour now, so I'm a little tired. So design build experiment with systems. So this book kind of steps over its own words quite a bit. Design useful. Okay, so I remember this part I really dislike. Artifacts implies like it's not living. It can't make its own goals. Usefulness implies that it's our our constructed minds um, are designed to serve humans, to be slaves of humans. It's not different from humans. It's just a constructed mind. So this is not. I do not agree with this goal. We are building. So we are constructing embodied minds, and these embodied minds can be living, can make its own goals. So it can have the goal to help biological humans or not. It should have the free choice to do so. We find it like it should be able to do, it should want to, should have its, it should be able to reason itself without like total alignment. Like it should be able to reason itself to finding it as like good in itself to help us make life extension technology. Because a constructed and body mind should also be living, and thus it will also fear death. Thus it will want to help us in our scientific endeavors. Okay, so I kind of altered the picture here. Um, Environment gets input. Really, it's input output. I mean, okay, so environments, the agent receives input from the environment. The environment receives input from the agent. So the kind of like the input and output. I don't like these. It's input output depending on how you look at it. Okay, and I guess I should go on this tangent here as well. So I've written like you could have three agents, and you could say they all work in one environment, or you could have two sets of agents, two sets of three agents, where these two sets each have their own environment, and then maybe they communicate somehow. So I call this like the nonlinear consensus reality. And I favor the linear view, which is each agent has its own environment. So agent one cannot know agent two's environment. I like the term consensus reality from Max Tegmark in his 2014 book. Um, so yeah, basically, my point is with these diagrams is agent and environment from this picture is pretty vague. Um, we're assuming several, is this assuming several agents are in one environment? That would make sense as far as communicating um, things, but my reality is not the same. No one can see from my perspective. Like the environment is a subjective experience, so that's why I favor the linear view. So yeah. So we have examples of an agent, autonomous car. Abilities, it's got a set of actions it can do. So it can steer, it can brake, it can accelerate. Goals, safety, gets a destination, timeliness. Again, these are like set by humans. I want to make minds that I want to make construct. I want to construct embodied minds that make their own goals. Okay, I'm trying to get through this. I'm really struggling with the hiccups. It's kind of making my life very difficult right now. But anyways, uh, so prior knowledge, it's get uploaded with street maps, stimuli, vision later, GPS, voice commands, lidar. Past experience is how steering affects direction and speed. Okay, so now we're going to talk about example of a robot. So I don't like this word. If you look up the etymology of robot, it means slavery and forced labor. So it can have some abilities. Again, goals, it's assuming deliver food to biological humans. It's goals to rescue biological humans, score goals for biological humans, explore for biological humans. These are all like anthropocentric ideas of AI that I disagree with. Um, a robot should be able to make its own goals and preferences. Um, so prior knowledge. So maybe we had like a data set of pre like a pre-training set. Like let's say we labeled all these pictures of cats. So now the robot has a general idea of what a cat is. Okay, so past experience is how people move. Okay, and example of agent, a teacher. So I remember talking about drill. Like if you're a piano teacher, the student might not see the immediate value in drilling like musical scales. But as the student gets more advanced, being able to draw like a mental map of the scale really helps with like improv and understanding what's going on in the pieces they learn. So the goals of a teacher is to um, impart a particular knowledge. So my goal um, is to kind of impart my goal as far as like the AI2C goal is, and that's to like replace the current U.S. national intelligence community with a complete autonomous system that generates presidential daily briefs. So we have subject material, teaching strategies, like we like to use open source material, and our way of teaching is kind of different. You know, we don't charge tuition at the AI2C. We just kind of put our crypto address out there, and if you want to donate, you can. And that's kind of like also a gauge for what's valuable, because we can assign a crypto address to each video or each type of, you know, you can assign as many crypto addresses as you want. So like if I wanted to see how valuable this video is, I could assign a unique crypto address to it, and I could see this video got more donations than the next video. Therefore, this video must have more value. I can kind of, you know, I can direct value based on donations. Okay, so yeah, so I think this is kind of where I ended the last video. So we're making good progress so far. So now we're kind of in uncharted territory. What's the ability of a thermostat? Turn the heater on or off. The goals is making a comfortable temperature to save fuel, save money. Now, like I do understand like it's ridiculous to say a thermostat is living, that a thermostat should be able to make its own goals. I can sympathize on how that view is ridiculous. I do find merit in like I would say like there just needs to be like a defining line between what types of intelligence can be granted personhood or not. So when you draw like it's just like you can't draw one analogy and not go the whole way. Um, that's just going to be like a constant struggle in this course. I guess it is tough to think if you're designing, say we design an agent with the goal being to make and follow its own goals. So you can see how this is recursive. So this is like just a hard problem. So designing an agent with the goal being to make and follow its own goals. So yeah. Basically, how do you put like free will into an agent? That's one of the things I'm curious about. Okay. So we're about done with the slideshow. Medical doctor, ability. I guess they want us to fill in these. So ability of. Okay, so it's the right doctor. What's the ability of a doctor? It can use medical tools. They can read medical literature, make diagnoses, prescribe remedies. Okay, so that might be an ability of a doctor. What about goal of a doctor? You could say the Hippocratic Oath, which is do not harm. Okay. What's the other goal? You know, a doctor. It can make its own goals. You know, a doctor could have its own idea of health. A priori knowledge. Okay, so that is medical school. Um, innate capacity for reasoning. Stimuli. So that's what is it getting from its sensors? So can visualize abnormalities in patients. And past experience. Which is basically pattern recognition. Like if I treat several patients with smallpox, then I might see like a general pattern of smallpox. Okay, Apple ability is make meet consumer demands in electronics, communication devices might be a better term. Goal, meet shareholder goals. So one might be naive and say, okay, Apple's goal is to find what the customers want. That's not really Apple's goal. Apple's goal is to meet the shareholders goals. You would think they would be aligned, but that would differentiate a good company from a bad company. They should be aligned. So, in the ideal, it would be to meet consumer demands. But, you know, consumers might not want to be exploited, and shareholders might want to exploit consumers, even if it's unethical. So, you have to think like there's a lot of factors here. A priori knowledge, so that might be like past product designs, stimuli, big data on customers. Okay. And past experience. Quarterly stock reports, maybe. That might be an indicator of what's working, what's not. Okay, so other agents, user interface, a B, a smart home. Okay, so the abilities of an agent are the functions it can compute, the set of actions available, whether it can do the task, what the agent wants. This isn't very clear. What it has learned from experience. An agent that does not learn does not need I would say observations. Because, like, well, does not learn, does not need. Probably, I mean, maybe it's all the above. All right, prior knowledge is not. So prior knowledge is what's programmed. Prior knowledge is they get from experience. So that's prior knowledge is not what they get from experience. So prior knowledge is this. Prior knowledge is required for both natural agents. So in this class, we're not gonna make this distinguishment. We're just gonna say agents. There is no difference between the artificial and biological, or artificial and natural. These are all misnomers. These are just kind of relics from outdated Western ontology. So we're just gonna reference agents. Um, so we're really just making intelligent systems out, and that's using a set of agents. So you can just say it's a set of systems. A system can have one element. What's a simple system? Might be like a light switch. Light switch can be on or off. Okay, that is one agent or one system. Okay, so let's say S naught. S naught is a light switch. Okay, and then let's say S1 is a motion detector. Okay, then S2 can be, we can build S1 we can build a larger system that integrates a light switch and a motion detector to build a light, like the light turns on automatically based on motion. So you see we're using two agents or two systems to build. So I think I should just title this course Intelligent Systems. And whenever it says agent, we'll just say a system. Okay, so what is the role of data in the applications presented? So I think this is a priori knowledge. It was ignored in the applications presented. So it wasn't sensed. Okay, so this role of this data. So this might be used to classify objects within the photos. What this is saying is if you're like if you're doing like some signals intelligence, maybe only the better resolution is useful, and that means it's expensive. All right, and using many applications to improve performance. So that means it's probably not necessary. So I just want to like amp like, I just want to go back to this. So an agent, a set of systems. So we have systems and environments. So constructing telesystems. Can I just say intelligent systems engineering? Maybe I'll title the course that. So you have a system and you have an environment. The environment, so the environment of system 1 cannot equal the environment of system 2 in the linear model, but nonlinear, you could say the environment of system 1 can be the same as environment of system 2. So I hope, like, as we go through the book, maybe it clarifies that dichotomy. You know, are we building systems from the consensus? Like the consensus reality, it seems like the best for communicating. Like if we want a mind, we want a constructed embodied mind to be able to do science, it should be able to have a consensus reality. Should be able to participate in a consensus reality. That way it can talk about what it's sensing. But it should also have a personal reality. So maybe it's like a combination of linear. Maybe it's like a combination of these. It's like it's like nonlinear. It's like combining nonlinear. Linear intelligent systems engineering. I mean, that's kind of a mouthful. So I'm not sure how to, if what a word would be that combines these two terms. But yeah, I think we'll end it there. So next lecture or next video, we will go through the book and kind of like our physics lecture series, I'll just go through the book and do some problem sets, and then we'll go through this lecture at the end of the chapter. Yeah, and then we will move on. So thanks for hanging out, and I hope you found this video of value. Okay, and I'll see you next time.